Hello, ma'am.
Good morning, students. Today we will continue with Unit 1, Topic 3. Unit 1 is Introduction and Water Applications, and Topic 3 is Types of Irrigation, Advantages and Disadvantages. What are the types of irrigation and what are its advantages and disadvantages? Number 1 is subsurface irrigation. Its advantages are: A. This method is suitable for forage crops, pasture, small grains, and flowers. B. Soils like sandy soils having low water holding capacity, high infiltration rate, good permeability are economically irrigated with high water use efficiency. C. This method requires almost 20 to 40% of water as compared to surface method. D. Seeds of weeds are not transported, reducing cost of maintenance. E. Labor charges are less than surface method. F. The same system can be used as a drainage system if required. What are the disadvantages? First is initial cost is more and is increased further if tiles or pipes are laid. Second is there is a loss of cultivable land occupied by trenches. Third, in this method, it is not possible to add manures and fertilizers. D. The perforated pipes may get choked. E. Waterlogging can occur. And F. Water with high salt content can't be used. This is a figure of subsurface irrigation. Number 2 is surface irrigation. Its advantages are: firstly, low cost of deployment, energy, and maintenance. Second, it favors the increase of the photosynthesis in the lower leaves due to the reflection of the light in the water. Third is the wind does not limit the irrigation. Fourth, it promotes the fixation of atmospheric nitrogen as a result of favoring the growth of blue-green algae. The disadvantages are: standing water can harm plants mainly by reducing the respiration of the roots, fairly dependent on soil slope. erosions frequent in the groups, and lastly, loss of water occurs due to percolation. This is a figure of surface irrigation. Number 3 is sprinkler irrigation. Its advantages are A. Suitable for all types of field condition. B. Uniform distribution of water with high efficiency. C. Less land loss provides more land area for cultivation. D. Loss of water is minimum. E. Accurate and easy measurement of distributed water. F. Soluble fertilizers, herbicides, and fungicides can be added in water before distributing to the crops. G. Reduces labor cost. The disadvantages are A. High initial cost. B. The water must be clean and free of sand, debris, and dissolved salts. C. Cannot be used in windy climate. And D. Fruits or crops can be damaged due to excessive water. And lastly, it requires high and continuous power supply. This figure it shows sprinkler irrigation. Students, please note down the assignment for lecture number 3. Thank you.
In much of the world, water is taken for granted. But in the desert, water is precious. In the desert, irrigation is the largest user of water. It's very important not to waste water when irrigating. The purpose of this video is to help you be a better irrigator and to show you ways you can save water. Irrigation is used for many purposes. Applying chemicals like fertilizers and herbicides. Breaking a soil crust so that young plants can emerge. Wetting up the beds or ground softening. But the most important use of irrigation is to replace water that plants need to grow. After an irrigation, water is stored in the soil for the plant to use. Only water that is within reach of the plant's roots is useful to the plant. The area where the roots are is called the root zone. Like a sponge, the soil can only hold so much water. The amount of water a soil can hold is called the soil's water holding capacity. Let's look at what happens in the soil when we irrigate. We apply water to the field so that a layer of water is sitting on the soil surface. The water on the surface seeps into the soil, filling the spaces in the soil with water. The longer the water sits on the surface, the more water seeps into the soil. The amount of time the water sits on the surface is called opportunity time. The water that flows below the root zone is no longer available to the plant. This excess water is called deep percolation. Your goal is to apply just enough water to fill the root zone without deep percolation. So far, we've looked at what happens in a small area of the field. Let's look at an irrigation of an entire row. You start water running at the head end of the field. We'll start our opportunity time clock at the head end. The amount of time it takes water to reach the tail end is called the advance time. Now we'll start our opportunity clock at the tail end of the field. The water running off the tail end of the field is called runoff or tail water. Now you turn the water off at the head end of the field and the remaining water seeps into the ground or runs off the field. The amount of time you left the water running is the set time. Notice that the head end of the field has a lot of deep percolation, where the tail end doesn't. This is because the opportunity time at the head end is longer than the opportunity time at the tail end. The difference in how much water enters the field at different locations along the row is called uniformity. Field A has a high uniformity. Field B has a low uniformity. This irrigation has high uniformity, but too much water was applied, resulting in water lost to deep percolation. This field is just right. Unfortunately, it's also impossible. We have learned about uniformity, deep percolation, and runoff, and how they affect how much water is wasted. But how do you control them? You can control two things: set time and flow rate. Let's look at how set time and flow rate affect your irrigation. We could minimize deep percolation by increasing the flow rate and shortening the set time. Notice that now we have less deep percolation. Unfortunately, we lose more water in the form of runoff. If we tried to minimize runoff by using a smaller flow and increasing the set time, our uniformity would be worse. We lose more water due to deep percolation at the head end of the field. Notice that if we increase the flow rate, we must decrease the set time. And if we decrease the flow rate, we must increase the set time. If you increase the flow rate without reducing the set time, you will apply too much water. And if you decrease the flow rate without increasing the set time, you won't apply enough water. For each field, there's a particular combination of flow rate and set time that will result in the least amount of water used, while still getting enough water to the plants. The best flow rate depends on the slope and length of the field, the type of soil, a heavy or clayey soil, or a light or sandy soil, the condition of the furrows. Dirt clods and plants will slow the water down, and the depth of the root zone. Early in the growing season, the root zone is very shallow and not as much water is required. Before we look at how to control the flow rate, let's look at some other types of irrigation systems that you might encounter. Some sloping fields have runoff, but the runoff or tailwater is used on other fields or pumped back to be used on the same field. On these fields, your goal is to reduce deep percolation without worrying about runoff. If we block off the end of the field, we eliminate runoff. And if we level the end of the field, we have more area for ponding the runoff water. This is called a modified slope. When irrigating a field with blocked ends, we take the water off of the row sooner than if the ends are open. This means we applied less water. Water that would have run off the end of the field is now used to irrigate the far end of the field. We still have some deep percolation, but no runoff, and we used less water. Finally, we can level the whole field. If we do this, we need to apply the water at a much higher flow rate. Since the field is not sloping, we need more flow to get it down the field. Most level fields have shorter runs to solve this problem. As you can see, if a level field is irrigated properly, we get a very good uniformity, with very little deep percolation and no runoff. Let's review what we've covered so far. Usually, when we irrigate, we want to fill the root zone without a lot of deep percolation or tailwater runoff. We can control deep percolation and runoff by changing the set time and the flow rate. The best flow rate and set time depend on the slope and length of the field, the type of soil, the condition of the furrows, and the depth of the root zone. The best flow rate and set time also depend on the type of irrigation. Sloped field with open ends, sloped field with the ends closed, modified slope, or a level field. The two things that you can control are the flow rate and the set time. The farm manager will usually decide what flow rate and set time should be used for each field, but if you see problems as you irrigate, you should discuss changes that you think might help. We've talked about flow rate a lot. Let's look at what flow rate is and how you can change it. Flow rate is the amount of water that is flowing in a ditch or furrow in some amount of time. For an irrigation canal or ditch, flow rate is usually measured in cubic feet per second, but may be referred to as CFS, feet, or feet of head. In some districts, the flow rate in the irrigation canal is given in miners' inches, or inches. Another flow rate to consider is the flow from the siphon tube into the furrow. This is usually measured in gallons per minute, or GPM. There are three things which determine the flow rate into a furrow: the number of siphon tubes into each furrow, the diameter of the siphon tubes, and the height of the water in the canal above the outlet of the siphon tube. Usually, you will know the number and size of siphon tubes you will use before you begin an irrigation, but you can adjust the height of the outlet of the siphon tube as you irrigate. By raising or lowering the end of the siphon tube, you can equalize the flow between all of the furrows, or give some furrows more or less water as needed. If runoff isn't a concern, increasing the flow rate and shortening the set time will reduce the amount of water wasted, but there are limits. Too much flow will cause scouring and may break out berms and furrows. Now let's look at some specific things that you can do to save water and prevent problems with your irrigations. First, you should learn as much as you can about the fields that you irrigate. Most of this information you will get as you irrigate different fields. But you must remember, fields will irrigate differently through the growing season. Some of the things you can look for are the type of field. Is it sloped or level? And are the ends blocked or open? Is runoff reused or lost? The length of the field. Does it have short or long runs? Or are the rows different lengths in the same field? Does the field have side slope or slope that is not in the direction of the rows? If it does, applying water too fast will break the furrows or beds between the rows. How much water does the supply canal get? The soil type. Is it a light soil with a lot of sand, or a heavy soil with more clay? Water will enter a light sandy soil much more quickly than it will enter a heavy soil. Does the soil type change in some parts of the field? For example, some fields will have bands or fingers of sandy soil over part of the field. Plants growing in sandy soils will look stressed earlier than in other parts of the field because the sandy soil holds less water. You will probably need to increase the flow rate to rows that have sandy spots so that the water will make it to the end of the row. Now that you know your fields, you should plan each irrigation before you irrigate. Before you start irrigating, you should know how many siphon tubes and boards or checks you will need to block the irrigation canal. You should also have extra siphon tubes on hand in case water isn't moving down some of the rows, or if more water is being delivered to your ditch than you planned for. How many siphon tubes per row? How many rows in each set, and how many sets to get across the field? How many hours for each set? Once you start an irrigation, keep track of how the water is moving down the rows. There are some ways you can change your irrigations to reduce water use. These methods will only work on some fields, and possibly only during part of the season. You should talk to your farm manager if you think one of these methods might help. Remember, if you irrigate with a low flow rate, you will have a smaller amount of tailwater runoff, but will lose more water to deep percolation. And if you irrigate with a high flow rate, you will have less deep percolation, but more tailwater runoff. It seems like you can't win. One way to solve this problem is with cutback irrigation. With cutback irrigation, you start the irrigation with 2 siphon tubes per row. When the water is about 2/3 of the way down the row, you cut back the irrigation by removing one of the siphon tubes. The siphon tubes you remove are used to start new rows. Here's a look at the whole field. Let's say you start your first set with 8 tubes. When the water is 2/3 of the way down the row, you move half of the tubes to a new set. When the first set is complete, move the other half to another new set. Then remove half the tubes from the first new set, continuing down the field. Cutback irrigation is difficult to manage because as you remove the siphon tubes, you need to start new rows. Remember, you have to use all of the water coming into your supply canal or you will overtop the canal. An easier alternative is to put 2 tubes in every other row of your set. When the water is 2/3 of the way down the field, you move the double tubes to the dry row. When the water is 2/3 of the way down the row, you move 1 tube back to your original row. Sometimes, particularly the first irrigation of the season, you can't get water down the row even if you use more siphon tubes per row. If this happens, talk to your farm manager about torpedoing the rows, running the rows with a tractor, or possibly using surge irrigation. With surge irrigation, you run the set until the water stops moving down the row. Then you move on to the next set. While you're irrigating the rest of the sets, the wet soil will seal, and when you return to your first set, the water will move easily over the sealed soil and onto the remainder of the row. It's almost like irrigating 2 short fields instead of 1 long one. To torpedo the rows, you drag a heavy metal cylinder down each row behind a tractor. This breaks up large clods which would slow the water down, and it seals the soil so that less water enters it, and water moves down the furrow more quickly. Running the rows works the same as torpedoing the rows, but you use the tractor wheels to do the work of the torpedo. Here are some more things to watch for while you're irrigating. If a row finishes early on a level or modified slope field, you can back water up into the row next to it. Make sure that water doesn't overtop the check. Don't let water flow onto roads, break out berms, or wash out the furrows. Don't let water pond for long periods, because this can damage some plants. Check the plants for stress as you irrigate. If plants are stressed, part of the field may not be getting enough water. Don't irrigate past your pre-planned set time. Depending on your canal's flow rate, you can waste from 1 to 300,000 gallons of water for every extra hour you leave your set running. Even though we've talked a lot about saving water, your most important job is to get enough water to all of the plants in the field. So look for obvious ways to save water first. Then you can fine-tune your irrigations over time while still getting enough water to the plants. If you're not sure that the plants are getting enough water, you can check how deep the water is going. Come back to the field 2 or 3 days after an irrigation and push a soil probe into the soil as deep as it will go. The probe will stop when it gets to dry soil. You should check a row at the head end of the field, the tail end of the field, and 2/3 of the way down the field. Out of all that we discussed, the most important points to remember are to plan ahead and to pay attention to your irrigations. With just these 2 points, all of the rest will fall into place.